E20 electrical system is quite similar to electrical systems which you are familiar with. It is simply more automatic and easier to use. There are two engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG. Each generator supplies alternating current, AC, to its own bus. Generator 1 to AC bus 1, Generator 2 to AC bus 2. Each AC bus supplies its own transformer rectifier, TR. AC bus 1 to TR1, AC bus 2 to TR2. The TRs convert alternating current into direct current, DC, to supply their associated DC buses, DC1 and DC2. DC bus 1 then feeds the DC BAT bus, DC BAT. The DC battery bus can charge the batteries or receive power from the batteries as required. This will be further explained in normal operation. The electrical system also includes two essential buses. The AC essential bus, fed by AC bus 1, the DC essential bus, fed by DC bus 1 via DC BAT bus. This is the basic electrical system. We will now introduce some other components which supply the basic system. The electrical network can also be supplied by the APU generator. These three generators are all identical, and any one of them can supply the entire aircraft electrical needs. On the ground, the aircraft can be supplied by an external power source. As a backup, there is a hydraulically driven emergency electrical generator, Emergen. The hydraulic power to drive the emergency generator is provided by a ram air turbine, RAT, located in the belly fairing, which extends in case of severe electrical or hydraulic failures. The electrical system is also fitted with an essential transformer rectifier, essential TR. The essential TR can power the essential DC bus from the emergency generator in case of severe electrical failure. Note, we will see the emergency generator and the essential TR in detail in the abnormal operation module. Finally, a static inverter allows part of the AC electrical network to be supplied from BAT1. Now, let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electrical page. You can see that most of the components we have talked about are displayed on the ECAM page. Let's briefly review the basic system using the ECAM electrical page. Gen 1 and Gen 2 supplying AC bus 1 and AC bus 2. TR1 and TR2 supplying DC bus 1 and DC bus 2. Two essential buses supplied by the left side. The DC BAT bus and two batteries. Notice that the static inverter is not displayed on the ECAM page. For simplification, the component indications had been removed. Let's now present them. As shown, each component can be monitored via its indications. These indications are voltage, current or load for the generators, frequency, IDG temperature. You can also notice the different connections displayed via green lines. Let's now locate the various controls available to the pilots and associate them with the components displayed on the ECAM. The electrical panel is located on the overhead panel. For emergency cases, there is an emergency electrical power panel on the left side of the overhead panel. Now let's look at the relationship between the electrical panel and the ECAM electrical page. The battery voltage can be monitored either on the overhead panel or on the ECAM page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch. The external power is also controlled by a push-button switch. We will learn how to use it in the normal operation modules. The AC Essential Feed push-button switch enables the pilots to change the feed for the AC Essential bus from AC bus 1 to AC bus 2. The bus tie push-button switch enables the pilots to isolate one side of the system from the other. You will see and do this in the abnormal operation modules. In case of failure, these push-button switches enable you to disconnect an IDG from its drive shaft. The controls and indications on the emergency electrical power panel will be covered in the abnormal operation modules. There is one exception. The emergency generator test switch is used by maintenance only to test the emergency generator. In this module, you have seen the electrical configuration on ground, with both engines running and with APU generator and external power available. We will introduce the different possible configurations in the next modules. Let's assume that we are starting with a cold aircraft for the first flight of the day. When you enter the cockpit, one of the first items that you have to check is the status of the batteries. To do this, first you have to check on the electrical panel that both batteries, BAT1 and BAT2 push buttons, are switched off. Next, let's look at the battery voltages. As you can see, both are below the minimum required 25.5 volts, so you will have to recharge the batteries from external power. To charge the batteries, you have to switch them on. Switch BAT1 on. Notice the off light has illuminated on the BAT2 push-button switch, because now the aircraft has electrical power to provide that indication. Switch BAT2 on. Because the green avail light is not lighted, meaning that you have no ground power, you have to ask the ground personnel to connect a ground cart. Click on the mechanic. The ground cart is now connected. The green avail light has appeared, which means external power is plugged in, its voltage and frequency are normal, it is ready for use. Switch the external power on. When the blue on light is illuminated, the ground cart is supplying the aircraft. The ECAM electrical page has been called for you. We can confirm that the external power is supplying normal voltage and frequency because the parameters shown on ECAM are green. By following the green lines on the ECAM page, you can see that the external power is supplying all the electrical system. Notice that because the engines are not running, the indications of the associated generators are in amber, and fault is illuminated in amber on the generator push-button switch. On the ECAM page, the battery voltage and current are shown. You can also see the green arrow, which indicates that the DC BAT bus is charging battery 1. Both batteries are now charging from the DC BAT bus. During this time, you can continue with your cockpit preparation. The average charging cycle is approximately 20 minutes. As you can see, both batteries have now disconnected from the DC BAT bus. There are no green lines connecting the batteries to the DC BAT bus. In order to check the battery's voltage, you normally have to switch them off. Switch BAT1 off. You can check on the panel that the voltage of battery 1 is normal. Notice the white off indication on the ECAM page and the off light illuminated in BAT1 push-button switch. Switch BAT2 off. As you can see, both batteries now have voltages above 25.5 volts. The battery charging cycle is complete. we need to switch the batteries back on. We will do this for you. Both batteries are now available. Voltage indications are now displayed green. It is time to start the APU and disconnect external power. We will start the APU for you. You can see on the ECAM page that the APU generator parameters are now displayed. Notice that the APU generator has not automatically taken over supplying the electrical system from the external power. This is because external power has priority over the APU unless external power is deselected. To select the APU generator, deselect external power. Switch the external power off. A green line has appeared connecting the APU box to the system. This means that the APU generator is now supplying the aircraft. You can see that the load is 63%. We can see that the external power is still available. However, we no longer need it, so it can be unplugged by the ground personnel. Click on the mechanic. The Avail light is extinguished, and the external power indications on the ECAM have disappeared. The external power source is disconnected. Let's look for a moment at the outside of the aircraft to see the only item associated with the electrical system on the walk-around. You should check that the external power access door is closed, if not in use. You have finished the normal operation A. We will continue with normal operation B. We are back in the cockpit, and it is time to start the engines. Usually, when we start the engines, the ECAM engine page is displayed. However, for training purposes only, we will keep the ECAM electrical page displayed throughout the flight. The electrical system is designed so that each engine generator will automatically come online and power its respective bus. We will start engine 2 first. Click on engine 2. The engine is running. Notice the generator automatically supplies the right side of the electrical system, leaving the APU to power the left side. Notice also that the fault light on the generator 2 push-button switch has disappeared. Engine 1 can now be started. Click on engine 1. The engine 1 generator takes over from the APU to supply the left-hand side of the system. The fault light on the generator 1 push-button switch has also disappeared. The APU is no longer connected to the system, and the APU generator is now showing 0% load. Once both engines are running, the APU can be switched off. Switch off the APU. The electrical system is now in the normal configuration for taxi, takeoff, and landing. In a normal flight, no further change occurs to the electrical configuration until the APU start on taxiing in. We have just landed and are taxiing to the gate. We will start the APU for you. The APU is now available and is standing by to take over from the engine-driven generators when the engines are shut down. Both engines can now be shut down. Click on either engine. Both engines are stopped. The APU generator is back online and has automatically taken over, supplying the entire electrical system. For training purposes, we will assume that the aircraft is to be completely shut down. So you have to request an external power source. Click on the mechanic. The Avail light on the panel and the external power indications on the ECAM have appeared, indicating that the external power source is plugged in and available. Select External Power On. The on light is illuminated in the external power push-button switch, and the green lines to AC bus 1 and 2 indicate that external power has taken over from the APU. We can now shut down the APU. Shut down the APU. The external power can now be switched off. Switch the external power off. When all the main power sources are disconnected, the CRT screens become blank. To shut down the entire electrical system, we must switch off the batteries. This will be done for you. All lights on the overhead panel have disappeared, except the Avail light, which is receiving power from the external cart. The battery voltage indications are LCDs and are wired directly to the batteries, so that they are always displayed. Now considered to be electrically shut down. This completes the normal operation modules. We will start this module with an IDG oil low pressure fault. So, let's assume that you are the pilot non-flying. You are in flight and everything is normal. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Observe the IDG low pressure indication in amber on the ECAM electrical page. Observe the IDG 1 fault light illuminated on the electrical panel. These indications mean that the oil pressure in IDG 1 is not sufficient. We can see from the blue action line that we are required to disconnect the IDG from the engine. The pilot flying will ask you to perform the ECAM actions. Perform the ECAM action. The push-button switch guard is up. You can now disconnect
Вирусная база
IDG1.
данных успешно обновлена.
Continue the ECAM action. Caution. Press the IDG push-button switch until the Gen fault light comes on, but not more than 3 seconds to avoid damage to the disengage solenoid. As you can see, Generator 2 has automatically taken over, and it is now supplying the entire electrical network. On the ECAM electrical page, an amber disk indication has replaced the previous low pressure indication, meaning that IDG1 is now disconnected. The IDG number is in white to indicate that engine 1 is still running. Let's look at the generator 1 indications for a moment. Gen in amber means generator 1 has abnormal parameters. One in white means engine 1 is still running. %, load in green means that the load is still within the normal range. %volts and 0 Hz in amber mean that the voltage and the frequency are outside the normal range. The amber fault light illuminated in the generator 1 push-button switch means that Gen 1 is not supplying the system. Alongside the Gen 1 box, a white galley shed indication has appeared, meaning that the system has automatically shed the galley equipment to decrease the load on the remaining generator. If available, the APU may be started, and the APU generator can then be used. After review and confirmation from the pilot flying, clear the electrical page. The status page is displayed for review. You can see in the Inoperative Systems column that the main galley and Gen 1 are now inoperative. After review and confirmation from the pilot flying, clear the status page. ECAM action completed. You have studied an IDG oil low pressure fault. We will now see a generator 2 overload fault. Let's assume we are in flight with no previous faults. Click on the forward arrow to activate the failure. On the engine warning display, read the title of the failure. Observe. the generator and load indications in amber on the ECAM electrical page, indicating that the load is abnormal. The galley fault light illuminated on the electrical panel, helping you to locate the switch. The galley will be switched off to reduce the load. Notice that there is no fault light in the generator 2 push-button switch because the generator is still powering AC bus 2. The pilot flying will ask you to perform the ECAM actions. Perform the ECAM action. You can see on the ECAM electrical page the galley shed indication has appeared. The generator 2 load is back to a normal value. After review and confirmation from the pilot flying, clear the electrical page. The status page is displayed for review. You can see that the galley is inoperative. After review and confirmation from the pilot flying, clear the status page. ECAM action completed. In this module, we will study an AC bus 1 fault. Before activating the failure, let's have a look at the ECAM electrical page. As you already know, AC bus 1 normally supplies AC essential bus and DC bus 1, which in turn feeds DC essential bus. If you lose AC bus 1, these same buses will be lost. We will demonstrate that the essential buses can be recovered using the AC essential feed push-button switch. Let's now assume that we are in flight and everything is normal. Autopilot 1 and autothrust are engaged. Click on the forward arrow to activate the failure. The SOP recommend in such a case that the first officer should fly the aircraft while the captain does the ECAM action. Note, another consequence is the loss of MCDU-1. The engine warning display is now displayed on the lower ECAM. Notice the green arrow which indicates other failure messages, not yet visible on the screen. You can read that the autopilot has disengaged. Let's deal with this first. To continue the procedure, you have to clear this line. Clear auto flight. The line concerning the autopilot has disappeared. You can notice that the Engine 1 ignition system and Engine 2 interface unit, EIU, have also failed. Actually, in case of AC bus 1 fault, these systems are not supplied anymore. We will clear these lines for you. Read the titles of the failures. As explained previously, AC bus 1 fault has led to AC and DC essential bus failures. The first line in the procedure shows us how to recover the essential buses. You will have to switch the feed of AC essential bus from AC bus 1 to AC bus 2. Notice on the electrical panel the fault light on the AC essential feed push-button switch. The pilot flying will ask you to perform the ECAM action. Perform the ECAM action. The captain's PFD and ND are recovered after a few seconds. The engine warning display is back on the upper ECAM. To continue the ECAM actions, you have to clear the Ignition B fault message. Clear Ignition B fault. The ECAM electrical page is automatically displayed on the lower ECAM. You can see that both essential buses are now recovered. For that, AC bus 2 is now supplying the AC essential bus, which in turn, via the essential TR, supplies the DC essential bus. Observe the new essential TR box with its parameters. On the electrical panel, the fault light on the AC essential feed push-button switch has been replaced by a white alternate light. This means that the AC essential bus is supplied by its alternate source, AC bus 2. Notice that DC BAT and DC 1 buses are automatically supplied by DC bus 2 after a short delay. As you can see, the only bus that remains unpowered is AC bus 1, which is displayed in amber. Let's now have a look at the ventilation panel. In case of loss of AC bus 1, the avionics ventilation system must be in the closed circuit configuration. That's why you will have to switch the blower push-button switch to the override position. Perform ECAM action. You have performed all ECAM actions relative to primary failures. Normally, at this point, you would have to examine the independent and secondary failures which are induced by the loss of AC bus 1. As you will see the complete procedure during your simulator session, let's assume that the ECAM actions are completed and that you have reviewed all ECAM system pages relative to secondary failures. The status page is now displayed on the lower ECAM. You can read the procedures to be applied following the failure and the list of inoperative systems. The overflow indication, green arrow, shows us that the list of inoperative systems is not complete. Click on the forward arrow to see the rest of the list. The electrical emergency configuration. As there are a lot of events which happen at the same time in the aircraft, we will present them in a sequential order. Let's assume we are in flight and no previous faults have occurred. Click on the forward arrow to activate the failure. As you can see, the first consequence is that the power supply for the first officer's PFD and ND, the captain's ND, and the lower ECAM is lost. The SOP recommend in such a case that the captain will fly the aircraft while the first officer does the ECAM action. Note, another consequence is the loss of MCDUs 1 and 2. Observe that on the emergency electrical power panel, the red RAT and emergency generator fault light is illuminated, meaning that the emergency generator is not yet online. After a short lapse of time, the RAT and the emergency generator light disappears. The emergency generator is now running and supplying the system. Notice that with the emergency generator online, the power supply to the captain's ND has been restored. Note, MCDU1 is also recovered. On the engine warning display, you can read that the autopilot has disengaged. Let's deal with this first. To continue the procedure, you have to clear this line. Clear auto flight. Read the title of the failure. The red emergency configuration title means that you are in an electrical emergency configuration. The red message, Land ASAP, orders to land as soon as possible. Observe that you have to maintain a minimum speed when the RAT is extended. Caution: below this minimum speed, the RAT will stall and the aircraft will only be supplied by the batteries. The pilot flying will ask you to perform the ECAM actions. You will try to reset the generators. Here, this will be done for you. The reset of the generators has not been successful. Before continuing with the procedure, let's look at how to access an ECAM page when the lower ECAM is not available. An ECAM page can be called up on the upper ECAM by pressing and holding its associated push-button key on the ECP. Call the ECAM electrical page. The page is displayed on the upper ECAM as long as the associated key is maintained pressed. On the ECAM electrical page, note that the emergency generator supplies the AC essential bus and, via the essential TR, the DC essential bus. As soon as the ECP push-button switch is released, the engine warning display is displayed on the upper display. As the previous reset of the generators was not successful, we will carry on with the procedure. Continue ECAM action. The bus tie push-button switch in the off position segregates the two sides of the system. By doing this, a short circuit can be isolated and might give you the possibility to reset one generator. The procedure asks you to try to reset the generators again. Here, this will be done for you. Again, the reset of the generators has not been successful. As the next steps concern other systems, we will stop here and study the indications on the right side of the engine warning display. Notice the amber nav, flight control and auto flight system titles. This means that these systems are affected by the failure. Their related procedures are stacked after the current one and will appear with the completion of the emergency configuration procedure. During the procedure, some secondary failures will appear. As the lower ECAM is not available, you will have to manually call the ECAM pages associated with these secondary failures on the engine warning display. You have to press and hold the related key on the ECP in the same way that you previously called the ECAM electrical page. We will now assume that the electrical emergency configuration procedure is finished and all the ECAM pages of the secondary failures have been reviewed. As you cleared the last one, memo messages appeared on the engine warning display. The green RAT out memo message confirms that the RAT is no longer stowed. The green emergency generator memo message indicates that the emergency generator is running and supplying the system. You will have the opportunity to practice the emergency electrical configuration procedure during your simulator sessions. We'll now study the case of a rat stall. At low speed during the approach, the emergency generator is no longer powered, and the supply is automatically transferred to the batteries. The ECAM electrical page has been called for you. Observe that the emergency generator indications have disappeared. As the battery discharge current is high, the current indications are displayed in amber. The batteries feed the DC essential bus and, via the static inverter, supply the AC essential bus. Both shed essential buses are automatically shed, which is indicated by amber shed indications below their respective buses. Notice that during this phase, the APU start is inhibited. On the ground, the DC BAT bus is automatically connected to the batteries. At low speed, the AC essential bus is shed, leading to the loss of all screens. We will now review some indications we did not have the opportunity to see when performing the previous procedures. As a result of the electrical failure, the RAT is normally automatically deployed. During the RAT extension, the electrical system is powered from the batteries. The approximate flight time on batteries is 30 minutes. Let's see what happens if the RAT fails to deploy automatically. If the RAT fails to extend, a specific line appears in the emergency electrical procedure telling you to manually extend the RAT on the emergency electrical power panel. We will do it for you. After a RAT extension, if the emergency generator is not working, the red fault light stays illuminated on the RAT and emergency generator indicator. This failure causes the aircraft to be powered only from the batteries. In case of smoke detection in the avionics bay, the amber smoke light illuminates on the Gen 1 line push-button switch. A master caution and an ECAM procedure are also triggered. When the Gen 1 line push-button switch is pressed, Generator 1 is disconnected from the system. Switch the Generator 1 line to off. The avionics smoke ECAM procedure leads to the shedding of the main bus bars. In this case, the electrical system configuration is the same as in emergency, except for the fuel pumps, which remain supplied.